An unknown charge sits on the solid conducting sphere of radius 10 centimeter. So you have a solid conducting sphere. What is the meaning for solid conducting sphere? Whenever the material is conducting, the charges will be sitting in the surface of the sphere. Am I right? So here they mention the sphere is the conducting sphere. So whenever you have the conducting sphere, charge should be sit on the surface. And this sphere has the radius. So better I am going to write something from this diagram. So we have the solid sphere. That means all the charges. We don't know what is the charge exactly sitting on the surface because we are going to find the value of the charge. But what is the radius of the sphere? So for example, if you see this diagram, the radius of the sphere is, what's the value they mentioned in the question? The radius of the sphere is 10 centimeter. 10 centimeter is the radius of the sphere. Okay. If the electrical field 30 centimeter from the center of the sphere has the magnitude of 3 multiplied by 10 to the power of 3 Newton per Coulomb. That means from the center of the sphere to a distance of 30 centimeter, how much of field strength you have? You have the value of 3 multiplied by 10 to the power of 3. So let's we take, I'm going to use the ruler. From the center to a distance. So let's we take, this is our distance. From the center to the distance of 30 centimeters. So what is the distance here? The distance from here to the center of the sphere, they mention, better I'm going to use the caps or, because we have to differentiate what is the radius, what is the distance. So here the caps or indicates the distance from the center of the sphere to the point. So what's the point they mention? They mention 30 centimeter, right? I think 30 centimeter, right? 30 centimeter. So the caps or values 30 centimeter. In this 30 centimeter, what is your electrical field strength? Your electrical field strength is 3 multiplied by 10 to the power of 3 Newton per Coulomb. So 3 multiplied by 10 to the power of 3 Newton per Coulomb. And it's radially inward direction. What is this radially inward direction? You have to see, brother, you have to read the question very carefully because this is a solid conducting sphere. All the charges will be sitting on the surface and we don't know what is the charge, whether it is positive or negative, we don't know. But here in this question, they give a clue. What is the clue they give? All the field lines are radially inward. So for which charge the field lines are radially inward? For the negative charge, it will be radially inward direction. For the positive charge, it's radially outward direction. Am I right? So for example, if you have a positive charge, all the field lines will be outward direction from the center. Am I right? Am I right or not? These things we already studied in the theory. But if you have a negative charge, all the field lines are radially inward direction. So what they given in the question, initially they said they don't know what is the charge, but they said the field strength, the field lines are radially inward. So that means the charge sitting on the sphere is exactly negative charge. Am I right? Am I right or not? The negative charge is sitting on the surface. That's what all the field lines are radially inward direction. Understand? Clear? So that means the answer today we are going to get is a negative value. We have to mention the sign. So how we are just mentioning the sign of the charge? Because in the question they clearly mention it's radially inward direction. So if the field lines are radially inward direction, it says the charges sitting on the surface of the conducting sphere is a negative charge. Understand? Okay. Now what we are going to find? We are going to find two answers for this question. In the first part, we are going to find what should be the net charge. We don't know the charge. We know only the electrical field. Am I right? So by using the electrical field for the point charge, I am going to find the value of the charge. So we already studied the formula. What is the formula for finding the electrical field for the point charge? E, which is equal to K Q over R square. Don't put small r, okay? Because this small r is the radius of the sphere. We are going to find what should be the electrical field, because based on this distance, the charges having the field lines radially inward direction. So I have to use caps R here, and by using this equation, I am going to modify it in terms of charge. That means I'm going to rearrange this equation. Therefore, Q, which is equal to E multiplied by R square over K, where K is the Coulomb constant, which has the value of 8.99 multiplied by 10 to the power of 9. And we have the remaining two values in the question. The value for the R from the center of the sphere to the distance is 30 centimeter, and the Coulomb constant is the constant which will be given, and the electrical field for this 30 centimeters is given as 3 multiplied by 10 to the power of 3. So I'm going to substitute the value. Therefore, Q, which is equal to, our electrical field is 3 multiplied by 10 to the power of 3 multiplied by our caps R value is 30 centimeter. So I'm going to convert that in terms of meter. So how I can consider? So 30 multiplied by 10 to the power of minus 2 the whole square, right? Divided by the Coulomb constant is 8.99 multiplied by 10 to the power of 9. So now I'm going to find the value of the charge. So better we can calculate by using the calculator. So 3 10 to the power of 3 multiplied by 30 10 to the power of minus 2 the whole square divided by 8.99 10 to the power of 9. So what answer we got? 3.00 multiplied by 10 to the power of minus 8. What's the value? 3.00 multiplied by 10 to the power of minus 8. And what's the unit for the charge? The unit for the charge is Coulomb. But now we have to mention what should be the value of the charge. As we already discussed, the field lines are radially inward direction. So what charge is exactly sitting on the sphere? The negative charge. So what should be our answer in terms of mentioning the charge? It is a negative charge, that is nothing but Q, which is equal to minus 3.00 multiplied by 10 to the power of minus 8 Coulomb. Understand? So this is the answer for the first part. This is the answer for the first part. Clear? Okay, now we have to find the answer for the second part. What is the answer for the second part? What is the charge density? Here they did not mention whether it is a line of charge, or that means the linear charge density or the volume charge density or the area charge density. Am I right? We don't know, but you have to see the diagram. This is the sphere. The charge is sitting on the surface of the sphere. That means this is nothing but the surface charge density. So you have to use the formula for surface charge density. So in theory we studied for the linear charge. What is the formula for linear charge? Linear charge, which is equal to charge over length, surface charge density sigma, which is equal to charge over area, and then the volume charge density rho, which is equal to charge over volume. All these things we studied in the theory, but for this question we have to use this formula. Why? Because here the charge is sitting on the surface of the sphere. That means we have to consider the surface area of the sphere. Am I right? So I'm going to use this formula for the second part. So let's start. So the formula for the second question is the surface charge density. Surface charge density sigma, which is equal to Q over A. What is this A? A is nothing but a surface area of the sphere. Why? Because the charge is sitting only on the surface. Am I right? Therefore, the surface area of the sphere is 4 pi r square. So therefore, sigma, which is equal to Q over, I am going to substitute the formula for the surface area of the sphere. The surface area of the sphere is 4 pi r square. Now, here I have to substitute the value of the charge. So what I am going to do, I am going to take the answer of the charge from the first part, and I'm going to substitute here. So in the previous question, in the previous part, we find the answer for the charge. So what's the value of the charge? Minus 3.0 multiplied by 10 to the power of minus 8 divided by 4 multiplied by pi multiplied by, what is our R? Because the charge is sitting on the surface. So what is the distance? Here the distance is nothing but the radius is the distance. Am I right? So I have to use this value of the radius. So in the question they clearly mention the radius of the sphere is 10 centimeter. So where if you just see any direction in the sphere, all the radius are exactly constant. So I have to use R value as 10 centimeter here. Clear? So that means 10 multiplied by 10 to the power of minus 2 the whole square. Understand? Now I'm going to find the answer. So take your calculator. Minus 3 multiplied by 10 to the power of minus 8 divided by 4 multiplied by pi multiplied by 10 to the power of minus 2 the whole square. So I got the answer as minus 2.39 multiply by 10 to the power of minus 7. What's the unit? Charge over area. The unit for the charge is coulomb and unit for the area is meter square. Am I right? So coulomb per meter square is the unit for surface charge density. Understand? So this is the procedure for getting the answer for the second part. But you should memorize, you should remember the formula for the surface area of the sphere. Clear? The surface area of the sphere is 4 pi r square. It's very, very important. So this formula will not be given. You have to remember this formula. Understand? Okay.